Hello, my name is Corbin, and today we are going to be doing a study guide for the CCSP from the ISC2 organization. The CCSP is the Certified Cloud Security Professional. It is a certification that is in high demand right now. I started to make this series because I recognized that there weren't that many CCSP study guides on YouTube. So I decided I guess I'll make one, and it'll not only help me study, but it'll help hopefully other people out there who are looking for good study material. I'm not going to say this is going to be perfect. It's definitely not going to be no Professor Messer. His videos are great production value. These aren't going to be at that level, but I will go through each chapter with you, and I will do my best to explain the concepts that are listed. The book that I'm using is the ISC Official Study Guide written by Ben Manislow. I highly recommend buying the book and utilizing it as well and reading through it. Additionally, there are some applications that I like to use for practice tests, but there are a bunch of practice questions in the book, and we'll go over those in separate videos as well. All right, so without further ado, let's go ahead and get started. First, let's discuss the definition of cloud computing. This is from the book. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources that can be rapidly provisioned and released with minimal management effort or service provider interaction. Some characteristics of the cloud would be broad network access, on-demand self-service, resource pooling, and rapid elasticity. So let's go ahead and start with broad network access. So broad network access just means that these resources are accessible from anywhere, from your standard OS browser. They're easily accessible, and the service can be given regardless of where you are. On-demand self-service just means that you can get the service as a customer on demand. It's real time. It's very scalable. Uh, and during this time, the cloud service provider can provide this service with little or no intervention um, in providing the service. Like I said, this is going to be not nearly as nicely done as Professor Messer. Resource pooling is the characteristic that allows the cloud provider to meet various demands from customers while remaining financially viable. The cloud provider can make capital investments that greatly exceed what any single customer could provide on their own and can apportion these resources as needed so that resources are not underutilized. Rapid elasticity is just the ability to grow and shrink resources as needed. This is a cloud concept indeed, because what it is if there's a company that needs resources for a peak time, but they use low resources for the rest of the time, they can do that within the cloud and be given more resources to meet that peak time. And this partners with metered and measured service. It's quick and scalable. Metered service, aka measured service, is basically like how the electric company charges you. You're only charged for what you use by this business model, and this is characteristic of the cloud as well. Now, business requirements. This is an important concept in the book. It said several times that business needs drive security decisions. There are two types of business requirements. There are functional and non-functional. Functional is a requirement, process, or personnel that is absolutely needed for the business to function, like a remote connection to a server. The remote connection needs to exist in order for it to be administered. Non-functional would be the securing of that remote connection. It doesn't hurt the function, but it's definitely something that's desirable, that you would want to secure that remote connection. All right, so the existing state. The existing state is exactly as it says, the existing state of the business. In order to get a good idea of the existing state in an evaluation, um, first you must do a full inventory of assets. Assets can be tangible, like hardware, routers, switches, etc., or intangible, like software code, methodologies, intellectual property. Processes need to be inventoried as well as business requirements. The methods for gaining this data start with interviews, interviewing functional managers, users, senior management, then surveying customers, collecting network traffic, inventorying assets, and collecting records, insurance records, financial assets, marketing data, regulatory mandates, etc. After all the data has been collected, a detailed analysis can be conducted, and then a BIA takes place. The BIA is an assessment of the priorities given to each asset and process within the organization. A proper analysis should consider the effect or the impact or harm or loss that each asset might mean to the organization overall. It's important to identify critical paths and single points of failure in a business impact analysis. And determining cost is one of the most important portions as well. After you've analyzed all the data, you can determine the cost of security controls, new hardware, replacements, anything like that, and determine if it's worth doing. So the benefits versus the opportunity cost. So for the cloud, there are many benefits, and there are some opportunity costs as well. Uh, the biggest driver for organizations toward cloud migration is cost savings. So capital expenditure cost savings is one type of cost savings. By using metered service, you're saving money in just paying for what you're using as opposed to running a whole data center and constantly paying for not only the power, personnel, all these things that you're outsourcing in a metered service manner. Operational expenditures are those expenditures I just noted for you. These would be expenditures in power as well, uh, people, and in business function. One important concept to note here would be cloud bursting. This would be augmenting of internal private data center capabilities with managed services during times of increased demand. Kind of like the concept of elasticity, but this is just renting managed services during times of increased demand as needed. We'll go a little bit more in depth on personnel cost reduction. IT are specialized and expensive personnel. It's not a baseline skill, so they will need to be paid more than a lot of employees. They also are not a profit gaining employee, so they're not going to be out there getting returns on their labor. They're just there to manage your IT. As far as operational cost reduction, operational costs consist of rent, power, all of these things that we've discussed before. There is a reduction there in most cases, depending on how much things you pack on to the service. It can start to add up pretty quickly. Regulatory cost transference. So this is where several cloud service brokers or cloud service providers will have compliance packages, and these will be set up strictly for these certain compliance rules, such as like the GDPR or the PCC PCI for the U.S. regulations. But they will have packages that are pre-configured to handle compliance. However, one important concept that is also repeated in the book is that no cloud customer can transfer risk or liability associated with the inadvertent or malicious disclosure of PII. So no matter what, if that PII is disclosed, it's still on the cloud customer and not on the cloud service provider or any other entity. And that concept is similarly defined as, say you were in charge of somebody else's property and you lent it to a third party and the third party lost it. Well, they're going to come after you. They're not going to come after the third party. You're responsible because you are the steward of their property. In the same meaning, the cloud customer is the steward of the PII and information. So data archive and backup cost reduction. Of course, doing cloud backups are a lot more simple, scalable. They're very cost efficient. You don't have to buy a whole new server when you run out of capability to hold data. And you can enhance your business continuity and disaster recovery plan with the use of cloud assets. We'll talk more about this in some of the later chapters. So some vernacular for the cloud. Elasticity, we've discussed that concept. It's the ability to go up or down in resources to fit a need, and it's timely and scalable. Simplicity, this just means a seamless use of service without frequently interacting with the cloud service provider. Scalability is the ability to increase or reduce services that can be more easily, quickly, and cost effectively accomplished than in a non-cloud environment. The cloud customer is the guy or the organization purchasing cloud service. Could be an individual, could be a company. Um, and the user, on the other hand, is just someone using cloud services. The user could be an employee who's using the cloud customer's services that they've purchased from the cloud service provider, which brings us right on to the CSP, Cloud Service Provider. These are going to be important. They're going to be hammered into the book, and so I would definitely recommend starting to memorize what the cloud customer is, cloud user, cloud service provider, CISPs, all these things, and starting to get a clear idea of their roles and responsibilities. So as far as cloud models go, there is IaaS, that's infrastructure as a service. This is the baseline type of service provided by cloud service providers. There is PaaS, which is platform as a service. This is most commonly used by developers. In this instance, this type of service, you would get the OS is loaded on instead of just the infrastructure. And then you'd be responsible from there with the software, anything you wanted to download their applications. Then there's, of course, software as a service, which is one we most know. That would be like Gmail, all these other cloud applications into which you have the software preloaded onto it. Another important concept that's going to be repeated in the book, cloud deployment models. So there's the public deployment model. The public deployment model is the most common. This is where several entities share resources. You can see those in multi-tenant environments, which are most environments, which just means that you are on, there is one server, let's say, in the cloud service provider's data center, and several tenants can be on that server within a public cloud. A private cloud, however, usually is segmented, whether logically or physically, in order to create a cloud that just has that one customer on it. These are used more for really sensitive data, IP, HIPAA, PHI, PII, and they're used sometimes together with a public cloud, and that would be a hybrid cloud. But for now, let's go to community. A community cloud has several different affinity groups that are attached to it. So this would be kind of like a school cloud where several universities are able to access this one cloud and collaborate together. These, of course, are a lot less secure than other clouds, but they're for the purpose of sharing and collaborating. And the hybrid cloud is a mix between any of the groups. Mostly that would be a public and a private cloud. You can have a public cloud and a private cloud as well in a hybrid cloud. So as far as roles and responsibilities go, there is the CSP, the cloud service provider, the cloud customer, the cloud access security broker, and regulators. So the CSP owns the data center that has all the hardware, employs the staff, manages the resources, monitors the service and provision security, and provides administrative access for the customer and the customer's data and processing needs. CSPs would be like AWS, Amazon Web Services, Rackspace, or Microsoft's Azure. The cloud customer would be the organization purchasing, leasing, or renting cloud services. Cloud broker, which is not listed up here, but there is a cloud broker. It's a company that purchases hosting services from a cloud provider who then resells them to its own customers. So consider them like a salesman of cloud services. Very important here is the cloud access security broker. This can be confused sometime, but it is a third party, this is from the book, entity offering independent identity access management, IAM, services to CSPs and cloud customers, often as an intermediary. This can take the form of a variety of services, including SSO, single sign-on, certificate management, and cryptographic key escrow. Regulators are, of course, the entities that make sure organizations are in compliance with the framework. Important regulations to take note of for this exam would be HIPAA, which is the Health Information Portability and Accountability Act when it comes to PHI, which is private health information. Gramm-Leach-Bliley Act, GLBA, the Payment Card Industry Data Security Standard, PCI DSS, the International Organization for Standardization, ISO, Sarbanes-Oxley Act, which is normally referenced as SOX, and regulators that would be included would be the FTC, SEC, ISO. Now, as far as foundational concepts, sensitive data, of course, that would be PII, PHI. Those are types of data that would be damaging if lost or taken. Virtualization, this is a concept that is strictly for the cloud. I'm sure a lot of you have used virtual machines before. This concept is what made cloud services financially viable as a business model. Cloud providers can purchase and deploy a sufficient number of host devices for a respective number of customers and users without wasting capacity or letting resources go idle. A cloud user can access a synthetic computer called a VM, virtual machine, and this is offered as just a piece of software, not an actual piece of hardware. There can be several virtual machines on one piece of hardware, the bare metal. There's also another concept which is called containerization, which is kind of like virtualization, but for applications, and it is much more dynamic and user-friendly. But they both serve different purposes, and we will go over those in a later point. Encryption. So in information security, encryption is used all over the place. It's used within the TLS handshake. It's used in full disk encryption, all these things. So as far as the cloud goes, there are several aspects and types of encryption. In this book, it's more about encryption for two things: data at rest, which is data that is saved, stored, or data in transit, which is data that is moving, which is being communicated. So it's necessary to encrypt both data at rest with something similar to full disk encryption within the cloud, and it's necessary to encrypt data in transit with something like TLS during your communications, or SSH for remote access. Encryption is an important concept, and we'll be going on into that in more depth here shortly. If data is not encrypted, of course, there's the problem of getting data intercepted by man-in-the-middles. There's eavesdropping. Additionally, there is the problem of pulling data at rest. Everything needs to be encrypted. Let's go to auditing and compliance. So, auditing and compliance are an interesting topic. There are several types of audits. There's a SOC 1, SOC 2. The SOC 2 has Type 1 and Type 2, and SOC 3. The most desirable type of audit to ask for, and hopefully you get as a cloud customer, is the Type 2 SOC 2. So SOC 2 Type 2. Majority of companies will publish a SOC 3 report, which is just basically says, hey, I passed an audit. That's all that's on the paper. It doesn't show the details. SOC 2 Type 2 gives you all of the details involved. All right, so as far as contracts go, another important term is an SLA, a service level agreement. This defines the terms and penalties that each party is responsible for. So if the cloud service provider is responsible for something and they fail, there will be a penalty, and that will be outlined in the SLA. This quantifies the goals of the business agreement, and it defines the responsibilities, finally, in the end, of each party. This is your contract that determines how everything's going to go upon migration. So related and emerging tech, there's machine learning and AI. Machine learning and AI are both kind of related in the fact that I think machine learning uses AI capabilities. So these concepts are actually being used now in the cloud. If you see some next generation firewalls, distributed firewalls, these kind of things, there are AI capabilities and machine learning capabilities, things like heuristics and within IDSs and IPSs, or heuristics within antivirus solutions. These are used quite a bit. Blockchain, of course, Bitcoin. It is the use of block data, and usually it's a transactional thing. So there's like the ledger, and that brings transparency to the movement of coins, crypto coins. And so all participants can view the ledger. For most coins, there are privacy coins. There are all kinds of coins. We can go to a whole nother thing, whole nother video about blockchain if we wanted to. But for now, just to be familiar with blockchain, it is a technology that is mainly used for cryptocurrencies. IoT, of course, Internet of Things. These are devices like embedded devices, everything that connects to the internet. Usually, IoT devices are more characterized like a smart thermostat, something like that, that has the basic functionality and is made just to fulfill that function, making it, not a very secure device. There was the Mirai attack where a bunch of IoT devices were subverted using basic credentials, default credentials, and used as a DDoS weapon. So something to look up if you haven't heard about it. Containers. All right, this is a logical segmentation of memory space on a device. Creates two or more abstract areas that cannot interface directly. It's commonly seen in BYOD environments where employees usually use their personal devices for work. The containers distinguish two distinct partitions, one for work functions and other for personal functions. So I would recommend going ahead and watching another video just on containers. It's a really in-depth subject, and it's actually pretty interesting once you get into it. Quantum computing, this is another technology that's just coming out. This allows IT systems to operate beyond binary math. This would use subatomic characteristics like electrons, spins, and charms to offer computation at an exponentially larger scale. Homomorphic encryption, this is an important one. This is a theoretical type of encryption. It doesn't quite exist yet, but this would be where the data is encrypted within the cloud, and the user or the customer can access the data while still having it remain encrypted. They never have to share encryption keys with the cloud provider or have to accommodate decryption as part of the process. It remains encrypted the whole time. But like I said, this technology is not out yet. So let's go over some basic terminology. The CCSP CBK is the common book of knowledge for this exam. Cloud computing, we went over the definition already. If you need to refer to that, please go to the beginning. A cloud app is just simply a cloud application. This would be an application that you either use or access within the cloud. A cloud architect, this is someone who manages and makes cloud applications, subject matter expert, and ensures that infrastructure and deployment is done properly. Cloud migration, this is when a company is moving all of their data and applications, other things, services, from an on-prem environment to the cloud. Cloud backup is the backing up of data to a remote cloud-based server. Cloud portability, this is the ability to move applications and associated data between one cloud provider and another, or between legacy and cloud environments. And this is an important concept when it comes to vendor lock-in or vendor lockout. Business requirement, we discussed that as well. These are requirements of the business. They dictate security decisions. FIPS 140-2 is an NIST document that describes the process for accrediting crypto systems for use by the federal government. An MSP is a managed service provider. This is where the customer dictates both the technology and operational procedures, and an external party executes administration and operational support according to a contract. They might maintain and administrate a data center or network for an organization. A cost-benefit analysis is a simple analysis of cost versus benefits to determine whether something is viable or necessary. Multi-tenant environment. So multi-tenant just means multi-tenant, many people within the environment or within a shared space. So this would be many cloud customers within the shared space of a cloud service provider's equipment. NIST 800-53 is a guidance document with the primary goal of ensuring that appropriate security requirements and controls are applied to all federal government information on information management systems. The TCI reference model is a guide for cloud providers, allowing them to create a holistic architecture, including the physical facility of the data center, logical layout, and the processes necessary to utilize both, that cloud customers can purchase and use with comfort and confidence. Vendor lock-in. This is when a customer is unable to leave due to technical or non-technical constraints. This could be because they're using proprietary software and all their data is locked in on that proprietary software. This could be because of bad contracts. We'll go over that more later. Vendor lockout occurs when a cloud service provider goes bankrupt or leaves the market, and then the customer is unable to recover or access their own data. So what's next? I'm going to make a video with some practice questions that are straight out of the book. You can go ahead and watch that whenever that comes out. Additionally, it's going to go over the requirements from the book, what you need to know. Definitely watch Chapter 2. That's going to be coming out soon. I'm studying as I'm making these, so just keep in mind, I'm making these to study and to help you study, whoever's out there watching them. And then, of course, read the book. The book is only like 30 bucks. I think on Amazon right now, maybe like 58 normally, but it's 30. So definitely get the book and supplement the book with this and other study concepts. Thank you so much for your time. I will be going ahead and putting some links in the description for the book and for some applications that I prefer. I'm not getting paid by anybody, so it's just stuff that I'm using. And I'll see you in the next one.